So if we keep looking at our Connect 4 game, what you can do is set up what are called unit tests in the main program. And the goal is to just make sure that your functions are working correctly. One common technique is called making a stub function. These are functions that won't actually return anything at the moment. We know that we need a function that does this, but we have not actually written this function yet. And what you can do is create what's called a scaffold. And that's basically where you're going to have functions you can call and test, but we may not have all of the details for how these functions work. So that's called a stub function. And so let's look at what we have for part 3 here. So we've already seen this thing for getting the board size, and we've got kind of typical headers here. We're using the IO stream, we're using a vector, we're using the namespace. So we're going to use a vector to store the board. And so a vector is sort of ideally suited for this because you can basically have a vector for the columns, and then inside each column have the rows and use that to kind of store a 2x2 set of information. So what we'll do, we'll create a vector, and then inside that vector will be another vector. This will be a vector of ints. And so what we're going to do is initialize the board. This is the function that we're defining. The name of the function is initialize board, and initialize board, the return type is a vector of ints. And so the inputs are going to be the columns and the rows. What we're going to do is we're going to declare a vector of ints. It's going to be a column, and we're going to have the rows followed by a 0. So we're basically going to fill in a bunch of zeros for all the rows. And then we're going to have a vector of ints, which is going to be columns by column. So column is just a bunch of, it's a bunch of rows that all have zeros in them. And then we're going to make every column basically just nothing but zeros all the way across. That's what this is designed to do. So then what we can do is we can initialize a game. And so this is going to be a function that doesn't have, the return type is just going to be the board again, which is a vector of ints. This doesn't actually take any inputs. We're going to have an int for C and R. We're going to get the board size, which we did up here. And then we're going to return the initialized board, which is this up here. So this is going to call the two functions above it, one where it asks how big of a board we have, and then the other where it makes a blank board where it's nothing but zeros. In the main program, we're going to create a vector of ints to create a board, and then we're going to define board. That's going to be what we get when we call the initialize game function. So if we basically do this here, what this will do, how many columns, we'll do 7, how many rows, 6. And so that executed just fine. Didn't actually display the board, but we did create a board from that. So let's see here. So we just kind of keep filling in the code bit by bit. This is the program in its entirety. We're not going to go over this in all of its detail, but we'll kind of look at it and talk about it here for a little bit. So we've seen the get board size. We've seen where we initialize the board. Here we've got a function that's actually going to display the board. And so basically what we're going to do is after we do what we just did, this function is going to return the board. And so this is actually going to display the board. So it's basically going to loop through all the rows. Then it's going to loop through all the columns. And we've seen this kind of thing before. And so if it's a 0, what we're going to do is output a period. That's what we're going to use to designate an empty space on the game board. Otherwise, if the board location, so this is basically like the coordinates, you know, if this is 2, 4 or something, 2, 4, it'll be the second column and the fourth row. We'll put a 1 for if it's player 1. We'll put a 2 if it's player 2. And so this is going to display the board with a bunch of loops. Here we're going to have a get move function. So we have an integer for the column. We're going to output instructions to the player. We're going to say, hey, player, whatever your number is, what column do you want to put your piece in? Column 1's at the left. And so they get to enter a value. Because computers and computer programs count things in kind of a weird way, in C++'s mind, column number 1 is actually column 0. So we're going to put this col minus minus. We haven't used minus minus as much, but it works the same as if you're incrementing with a plus plus. It's just this is called decrementing. You're going to decrease by 1 over and over. So this is just going to basically shift all the column values by 1 spot. And so we're basically going to say to the player, which column do you want to put a piece in? Then what we've got a place piece column. So this is the column that it's going into. Here's all the information for the board. We've got the ampersand because we're passing by reference because we don't want to use up more memory than we have to create a copy of the board. And then we're going to get an integer for the player for whoever's turn it is. We're defining something called last empty. And then as long as we are, as long as we're below the value of the size for the columns and the rows, we're just going to keep filling in these. And essentially what this is doing is it's keeping track of whether or not the board has filled up in its entirety, is basically what it's doing. So a 6x7 board is going to have 42 spaces. This is essentially going to keep a running count of how many spaces we have used. And we're going to use that because there'll be a thing to decide if there's a tie, basically. Here we've got a bool. A bool is either true or false. So this is to check if there's a vertical winner. And we won't go over all the gory details of this, but this will basically check and see if all the pieces arranged vertically will match each other. And so essentially you're going to do a loop through the row numbers is what that is doing. Then you got another one for horizontal where we're going to check and do the check and see if the rows are all going to match. That's what these are all doing down here. Just make sure they all match. And then you've got another one for the diagonals where you've got to, depending on which way you're going, you're either going to decrease the row and increase the column, or else increase the column and decrease the row. So there's one for each of those for the diagonals. And so these are all just a bunch of complicated checks to see, do these things match or not? And then lastly, this is the thing I was mentioning earlier. So like we're going to check to see if the board is just filled and no one has won. That's what this function would do. And then we basically have this thing for checking a winner. So check to see if player 1 or player 2 is the winner. And you do all these different checks. Did they win vertically, horizontally, either of the diagonals? And then if none of those returns a winner, then you check to see if the board is full, because if the board's full, the game is over. And then here we're just going to print the winner. This should look familiar because this is actually pretty much the exact same thing we had up here. It's just these are for all the cases when player one wins, and it'll output the message, hey, player one won. And then you got player two wins, otherwise it's a tie. So we got all this stuff here. And let's see, what is this? This is initialize game. We saw that function already. We've got a take turn function. So we're going to, what's the turn consist of? We're going to show the board. We're going to get their moves. So they're going to type in a number where they want to put their piece. We're then going to place the piece. So we're going to record the move, display the board, update and display the board, and note which player it is whose turn it is. And then after they take their turn, we just check to see if they won. Then we declare who the winner is. We display the board and print the winner. So we have functions that do both of those things. And then when all is said and done, now we're at the main program and we're going to make a board. We're going to initialize the game. And then we're basically just going to, this is going to go back and forth for player one's turn or player's two turn. So, so we're basically going to start at player one, and then this is going to cause it to swap over to player two. And then otherwise, if it's not player two's turn, then we go back and do player one again. And when we do the take turn function, we record which player is going. And so then when it's, while the player value is 1, we're going to reset it to 2 after we do their turn. And then we do it again while it's player 2. And then if it's not player 1, it's going to skip down to the else and then go back to player 1. So anyway, if you run this program, you can play like a game of Connect 4 or something. So like how many columns? We could have, what is it, 7 and then 6. So there you go. There's a picture of a whole bunch of dots. Let's just go in like spot 3, for instance. Now you can see where my piece is. It's player 2's turn, so they're going to go in 4, and it's going to just keep on going here. We're going to go to 3 again. He's going to go to 4 or 2. I hit the wrong button. Then he goes to 3, and then player 2 is going to go to 3 to block him. And then, you know, the game will just keep going like this. But yeah, that's Connect 4. So anyway, very sort of summary overview of this. The main thing is, like I said, the idea with something like top-down design is you really start big picture. What do you need this thing to do? And then you create functions that do each of the distinctive components of what your program needs to achieve, and keep sort of testing it bit by bit to see if the individual components work okay, and then you can kind of move on to other tasks.